Never think that it is a very small question or I can clarify later, asking the friends. Not that way. You are absolutely free to ask, even it is a nothing called silly questions. Any questions, whenever it comes to your mind, please ask. There is no barrier at all from my side. I will try to explain. Those who are PhD students, I think all are geology PhD students, isn't it? Some 5-6 PhD students are there. Good that we have a big range of students, right from second MSc to geophysics to PhD students. Now, all my earlier classes now, whatever I have taught, the second MSc students here and partly in IIT Bombay, so they are all in YouTube. Sometimes you should see and enjoy, because many things, interesting things I talk during Tectonics and Crustal evolution class, particularly while describing the geology of Aravalli, geology of southern ground terrain, because I have the experience of working in almost all the terrains of India, almost all the terrains, including the Himalaya also. So many times, during field work, a lot of good field experiences are there. So I try to share with my students. So you should see those videos. You will enjoy it. Okay. So today, what I have planned, I will teach in a different way. In the sense, let us see the geology or the geography of the entire globe, entire world. I will draw it in the blackboard. Try to tolerate the quality of drawing or quality of the figures. First, I will show it in the screen. Can you just mirror show it on the screen? Not to the screen. I'll just focus it. Yeah. So let it come on the screen. In the meantime, let me draw. What I will draw, you see, just I'll write down. This is North America, this is South America, this is Canada, North is Canada. Then here will be your Greenland, here will be Greenland, then here will be Europe, the Scandinavian countries, then here there will be France, all those things. Then this side is your Africa, this is South America, then this Asia will continue like this, China and Asia. Here is your gigantic Himalaya. India is somewhere here. Let us show India very prominently. India is here. Then this side will be Japan, Philippines. Then it comes down to Australia. You are showing the blackboard, no? Australia. This is Africa. Roughly, I have drawn this map. Are you able to understand this map? So you can compare these things on the screen. I do not know how far it is visible to you. Is this not focused to the screen?
Yes, sir.
Okay. Now you can see the Africa. Africa is in the center. India. Then the entire thing is Asia. South America, North America, Australia. And these are your Sumatra, Java, Japan. All those islands are there. Now, most importantly are the oceans. So these are the continents I have drawn. But in between them you have the oceans. This is the Atlantic Ocean. This is the Atlantic Ocean. So you can say North Atlantic, South Atlantic. But it is a continuous ocean. Then you have Indian Ocean. Then if you go to the other side, You have Pacific Ocean. Pacific Ocean continues to the other side of the globe, and here is your America. This is your Pacific Ocean. These are the three important oceans: Atlantic Ocean, Indian Ocean, and Pacific Ocean. These are the three important oceans. Very large oceans as you see in the globe. Now, these oceans, very deep oceans, 6, 7, 10, 12 kilometer deep oceans are there. And the others are the continents. Now, if I ask you, these oceans, they have the sediments. So, if one can date those sediments, what is the age of those sediments? So, he can tell how old are the oceans. That is the basis. To understand how old are the oceans, you have to date the sediments in it. Now, Atlantic Ocean, Pacific Ocean, Indian Ocean, whatever sediments are there below, they have been dated. There are various means, argon datings, our department is in zircon dating. So many dating methods are there nowadays, you might have read in isotope geology class. So by dating those rocks, which rocks? Sedimentary rocks. It has been found that the oceans which you see today, they are maximum 200 million years old. 200 million years old. Indian Ocean, Pacific Ocean, maybe another 10, 20 million years, this will plus minus. So oceans are very young compared to the continents. The continents like this continent, they are very old. They contain many old rocks. As old as nearly 4 billion years old rocks are there in Canada, Australia. Very old rocks are there. So continents are always older. So it is said India, suppose I ask you what is the oldest rock in India? Maybe 3.7 billion years. Oldest rock, you can say the Bastar Craton which is there. 3.7, 3.8, there are some zircons in Bastar Craton. So we have dated, myself and one Australian geologist together, we have dated some zircon that produced something around 3.8 billion years. So that is the oldest rock in India we are having, not beyond this.
Sir, Sir, what about Chambua granite, Chambua gneiss?
See, that granite somebody or gneiss somebody has dated it to be around 3.9 or 4. See, that is still doubtful. That has been challenged. So we do not have beyond 3.8. So if somebody quotes it at 3.8 is fine, people will accept it. If you go to 4, people will not accept it from India. So you can assume the Chambua gneiss or the OMG. You are talking about from Singhbum crater, na?
Yes, sir.
Yeah. So it will be 3.8, not 4. Some older reports are there, it is 4, 3.94, but it is not that old. See, because the methodologies now, sometimes they have been challenged. Initially they were doing some rubidium strontium dates. Later the zircon dates came. So like this it has been revised. So you can say the maximum 3.8 billion years. Aravali 3.5, Sardur 3.5, 3.4. So this is the maximum. But Canada, there are some gneisses, Australia, which is 10 to 4 billion years. So that is the oldest. What I am telling you, the continental crust is so old. But ocean rocks are so young. So what has happened? All these oceans which you are seeing today, they have formed only during Cretaceous or Jurassic, Triassic. During that time it has been created. 200 million year means what? End of Jurassic. They have been created. These oceans were not there. There may be some other ocean. Paleozoic time there are some other ocean. Proterozoic time there are some other oceans. Those oceans are where? Those oceans are destroyed, collapsed. You can use this language: collapsed, sunk into the mantle. Whatever rocks were there inside the ocean, they have been crumpled, deformed. Those Proterozoic time oceans are there. Paleozoic oceans, they were there, but they were not existing now. So whatever rocks were there inside, they have been crumpled, deformed. So in those places there are mountain beds. The most classic example is Himalaya. Himalaya mountain bed is produced from a pre-existing ocean. That is Tethys Ocean. Tethys, some people say Neo Tethys. Let us remember it, Tethys Ocean. So Tethys Ocean was a Paleozoic ocean. Where you are seeing Himalayan mountain bed, there was a Paleozoic ocean, Tethys or New Tethys, whatever may be. So that collapsed, that was destroyed, and the whatever rocks it has accumulated, sedimentary rocks it has accumulated, they all crumpled to form this mountain bed. Like this, Proterozoic time. There are many Proterozoic mountain beds. If you take India as an example, so many Proterozoic mountain belts are available. Central India Tectonic Zone or Satpura, Singhur, Eastern Ghats, these mountain belts are not Proterozoic mountain belts. Some are Paleoproterozoic, some are Middle Proterozoic, some are Neoproterozoic. But they all belong to Proterozoic mountain belts. So those mountain belts came from where? There must be some ocean there. So those oceans are no more existing. Whatever rocks it has accumulated, they have been crumpled and formed the mountain bed. A part of the crust now, part of the continent now. Just like Himalaya has become a part of continent, China, India continent. Similarly, those mountain beds were part of ocean once upon a time, now they are part of the continent. Like this Archean time, there may be some other ocean. So those older oceans are no more existing. Though older crust is existing, but older ocean is not existing. You should remember. Now, point is, what today I am going to tell you. Now let us take the case of Atlantic Ocean. Atlantic Ocean. Now if you see the Atlantic Ocean, because the Mother Earth is so kind, it is covered with water. ये वाटर सूख जाएगा ना, उसका अंदर क्या क्या है आप देख के बच नहीं पाएंगे। ओशन का अंदर आपको तो क्रस्ट बहुत सुंदर लगता है, हिमालय माउंटेन बेल्ट बहुत सुंदर लगता है, रॉकी आंडीज बहुत अच्छा लगता है घूमने के लिए, आप जाएंगे सभी कभी फ्यूचर में, स्विट्जरलैंड बहुत अच्छा लगता है। बट कभी आप ओशन को सुखा दीजिए, उसके अंदर जो मिलेगा सब पहाड़ी, वो आपको कैसे लगेगा? उसके अंदर ऐसे एनिमल्स आर देयर, यू कैन नॉट टॉलरेट देम। Such big and furious animals are there inside the ocean. Now, if you see that Atlantic Ocean, at the center, you have mid-oceanic ridge. Mid-oceanic ridge. Almost all the oceans, Indian Ocean, you have mid-oceanic ridge. These are mid-oceanic ridges inside Indian Ocean. Similarly, Pacific Ocean, you have mid-oceanic ridges. Mid-oceanic. Now, mid-oceanic ridges are the creation of the ocean. From there, the ocean is created. Otherwise, Suppose the Atlantic Ocean, you see the mid-oceanic ridge. Although he had this ridge was not there, then Africa, Europe and America were together. They are forming a single continent. If you remove the Atlantic Ocean, so here the mid-oceanic ridge was created. So gradually they were broken apart like this. Like that. Indian Ocean was created. So India, Africa, Antarctica all together. They are forming a single continent. Now they are occurring at different places. Similarly, Pacific Ocean, other side. So mid-oceanic ridges creates ocean. That's why it is called a creative boundary or divergent boundary, people say. The new crust is created, oceanic crust is created. Mid-oceanic ridges. Now, this mid-oceanic ridge more or less occurs at the center of the oceans. Now, what else ocean has? Ocean has also some subduction zones. Ocean ke andar there are subduction zones. These oceans are going inside the mantle. These oceans. The most important subduction zone I will tell you in the Pacific, bordering the America. There is a subduction zone here. Bordering America. Subduction zone. It is in the ocean. Another subduction zone, you will find here Japan, Philippines, Tonga. Tonga where the eruption was taking place few days back. Tonga, Andaman. So this is another subduction zone, which way it is subducting? Yeah. This is another subduction zone. So ocean के अंदर these are called tectonic features. Very large scale. Entire ocean is covered by mid-oceanic ridges or the subduction zones. Transform faults are there also, we will read. But today we will not go to that side. We will focus in some other line. Now, you come to Atlantic Ocean. Atlantic Ocean, you have these continents, both sides, center you have this mid-oceanic ridge. The continental margins, these continental margins, CM I am ready, continental margins, they were together, this side, they were together, now they have been separated. So along the continental margin, there is no tectonic activity. Oh, calm and quietly, just like a boat, they are going from the center to the mid-oceanic ridge away. So these type of continental margins are called passive continental margins. Passive continental margin. Understood now? PCM, where the continent's margins are not having any tectonic feature. Atlantic Ocean is a right example of passive continental margin. But where along the continent there is a subduction zone like this, there is a subduction zone along the continental margin. So this is not passive. This is an active continental margin. Active continental margin, ACM. PCM, SCM, these two you know. Continental margins are classified to PCM and SCM. So definition is very easy. If the continental margin is having a tectonic feature like subduction zone, it is active continental margin because deformation is going on, subduction is going on, lava is erupting. But passive, where there is no tectonic activity along the continental margin, that we say passive continental margin. Now Indian coast you see, India one side is India, other side is Africa. There is no, along Indian coast, there is no tectonic activity. So this continental margin is a PCM margin, western side. Eastern side is also a PCM margin. PCM margin. No tectonic activity along the coast. But suppose I ask you, Andaman Nicobar Islands are there. What type of margin they have? Active continental margin. Because Andaman Nicobar, they are trenches, they are subduction zones. Similarly, Japan, active continental margin. Because they have a subduction zone there. So the basic definition is wherever there is a subduction zone along the continental margin, you say is active continental margin. Passive continental margins are those where there is no tectonic activity along the continental border. This you remember. All these things happens inside the sea. It does not manifest outside, except sometimes volcanic eruption as I told you, Tonga, Japan. These are the places where continuously volcanic islands are taking place, volcanic eruptions are going on. But we enjoy those things. Vast sea and there is a volcanic eruption. Everything is red, clouds are floating for days together. Lot of dust, smoke are coming out. So from a distance, sitting far away, 2000 kilometers away, through a binocular, we are looking at it. Very enjoyable. But if I open the entire ocean, if I dry out the water, you will see how horrible is the ocean floor. That is the thing. So, these continental margins are passive or active. Now, what is today we are going to discuss, Let us imagine another 200 million years afterward. All these oceans will be again collapse. These oceans will collapse. I told you they are not permanent features. Oceans are not permanent features. They will collapse. Atlantic Ocean, such a big ocean, linear ocean you are seeing, it will close. All those continents sideways, they will come together again. Indian Ocean, you are seeing such a vast ocean, up to Australia it is extending. This will close one day. They are not permanent features. Whatever you see, they are only 200 million years old. Similarly, after 200 million years, they may not be there. So in those places, there will be mountain beds. Just like Himalayan mountain bed, There is a very vast ocean, just like Pacific Ocean. Tethys was existing here, even larger than Pacific. Tethys Ocean was existing here. So that was closed. So now in its place you are finding a mountain bed. Similarly, all those oceans will close and form the mountain bed, Atlantic mountain bed, Indian Ocean or Indian mountain bed. They will form Pacific mountain belt. They will form, and oceans will be not there. Some new oceans, somewhere within China, there will be big ocean will be created. China will be broken into small pieces. So those things are there. It is not very far. Of course, it cannot happen within our, but this is going to happen. This is going to happen. Oceans will take bath, oceans will close, oceans will die. Again, new oceans will be created. That will again die. After say 400, 500 million years, those oceans. So maximum one ocean can exist up to 500 million. Maximum. उसके आगे नहीं है.
Sir, why did you say that China will
Hey, रोको. China नहीं मैं पाकिस्तान बोलता हूँ. See, a big continent. This is a big continent. This is called Eurasia continent. So Eurasia continent consists of China, Europe plus India. This is Eurasia. Now, suppose this Pacific Ocean closed or the Atlantic Ocean closed. So those big continents, will try to split. So if there is a weak zone within those continents, those weak zones will be tempered. यहाँ से I will break. So which is the most vulnerable site in this Asian or in this Eurasia? The Himalaya will be again vulnerable. Himalaya is a very weak zone. So somewhere within Himalaya or very close to Himalaya, it will break. Again, China and India will be separated. Like this. America. If Atlantic Ocean closes, somewhere within America it will split. These continents has to split, no?
Sir, but the Himalaya has a thick root inside the crust.
Himalaya
Himalaya has a thick root, sir, inside the crust.
Thick root, today you are seeing. Today you are seeing the thick root,
Yes, sir.
After 200 million, root किधर चला जाएगा? वो Himalaya is rising, ना? Himalaya is rising, वो root जो है ना, ऊपर आ रहा है. That 80 kilometer crust, more is 80 kilometer down, na? It will come to just 40 kilometer. Why it will come to 40 kilometer? ऊपर से erosion हो रहा है, बारिश हो रहा है, erosion हो रहा है. The sediments are being removed from top of Himalaya, going to Bay of Bengal, going to Arabian Sea. It is loading those oceans now from Himalayan sediments. Then what will happen? Root cannot remain 80 kilometers all the time, because the peniplanation is happening. The more peniplanation, the root will go up. Like isostatically, as you see, a higher mountain belt has a deeper root. This is for isostasis. Similarly, a lower mountain belt will have a lower root, shallower root. ऐसे भी आरावली का भी बहुत बड़ा रूट था, बट बेचारा अभी आरावली का रूट नहीं है, क्योंकि वो दिस इज ओनली 500 मीटर हाई. इसका रूट अभी नहीं है, निकल गया. All those mountain belts, Alps you are seeing today, na very deep roots, very large heights, they will all be peneplain. They are loading the ocean. To certain extent they will be loaded. They are loading, and once that overloaded, then ocean will collapse. That is the time. Another 200 million years. I am giving you a safe time for loading. कितना भी लोड करो अरेबियन सी को, इंडियन ओशन को, it will not have any effect now. But another 200 million years के बाद, the entire ocean will be unstable. पूरा हिमालय will be there inside Indian Ocean. पूरा sediment चला गया उसका अंदर. So what will happen to the oceanic crust? It will come down into the subduction zone होके चला जाएगा. Mental. यही तो चल रहा है. This is the things going on for last so many years. So Himalaya is now a youthful stage. Aravalli पंख हिला के पंख चला गया उसका. He has come to the old stage. Aravalli. It was once upon a time also a mountain belt like Himalaya. So that is the thing. Deep root. Now you are seeing, but once all these roots will come up, the whole thing will be exhumed. The deeper rocks or deeper levels of rocks, they will be exhumed to the surface. So this is the fate of all mountain belts. Nobody will escape. Understood now this point? So now point is, what I am telling, suppose this is Atlantic Ocean. Atlantic Ocean, there is a big mid-oceanic ridge. Now if you see Atlantic Ocean map in detail, I will draw it. That is the point which I am going to tell today. You see, or even Indian Ocean you see, the Pacific Ocean, any ocean you see, ये बीच में आपका मिड ओशियन रीज है, ये मिड ओशियन रीज at the center. Now this side the continents are there. This side the continents are there. Continents are there. Now if you see the Atlantic Ocean, you must have read in sedimentology. So if you just take a cross section, from this to that, it will have a shelf, then there will be slope, continental slope, then deep ocean, something like this. The deep ocean will coincide with this mid-ocean areas, and the same part very close to the continent. Both sides, shelf parts should be very close to the continent and gradually shelf. So up to this, the continent is extending to the edge of the continental slope. Similarly, this side also, continent is extending. So how much it extends, it depends on the continental material, the mid-oceanic structures, many things it depends. How far the continental slope extends or continental shelf extends. Maybe approximately you can say 1 or 2 kilometers from the margin, 1 or 2 kilometers from the margin. So maximum depth, these are safe figure I am telling you, 1 kilometer. This may be 2 to 3 kilometers, let us see. 2 to 3 kilometers. Varies from place to place. Continental shelf, then slope, then the deeper ocean. Deeper ocean means your oceanic crust will be there. Your oceanic crust will be there. Basalt, उसका ऊपर sediment deposit होंगे. But जो continental shelf है, ये सब continent के part है, granitic part है, उसका ऊपर sediments are deposited. Your sandstone, shale, limestone, ये area में. So this is your the platform, self platform, very horizontal, undisturbed, high energy condition there. So you will find very flat bedded deposits, sandstone, plastics and carbonates. The proportion varies. Sometimes the entire thing will be carbonate, very little plastics. But dominantly they will be very close, as they are very close to the continents. There are a lot of sandstone, shale, limestone will be less. That sort of association will be there. Close to the continent, self-environment. But as you go down, there will be deeper sediments, salts, carbonates will be there, deeper sediments will be there. You must have read in your sediment classes. So these platforms are understood are very tough, horizontally bedded deposits. platform. So you will get a real platform deposits here, in the self-environment. This side also platform deposits. India also, Bay of Bengal, to 1 or 2 kilometers you will get these platform deposits. Shale, sandstone, limestone. The proportion varies. Limestone may be less, may be more. So depends on how deep is the continental crust there. Continental crust. But as you go down, this is very deep. And the northern sea, the Greenland, Europe, the entire thing is self. There is no deep sea there. Maximum 1 kilometer thickness of water. Everything is flat. Everything is platform deposits. So one is the deep sea deposits, another is the platform deposits. Near the continental margin you will get platform. See, if you come down to this side, Florida, Bahama, where North America, South America, beach में जो Caribbean countries are there. Small continents are there. The ocean is around like here, Mountain, Florida, Bahama, Jamaica, all those small land masses are there. Country here. This is the ocean. There is shallow level oceans. Because continents are very nearby. They cannot be deep ocean. So those platform deposits, like it's horizontally bedded, ऐसा करके सब रहेंगे. Then they will be subsiding. Another phase of sedimentation will start. So, if you just remember map of Canada you remember, now there are so many seas, within Canada. Within Canada, there are several seas, within the continent. Within the continent, there are several seas, oceans. छोटे. Some are connected to main Atlantic. Some are purely continental within the continent. So those type of deposits, those type of seas. Some name, if you has read, Epiric Sea. Which are Epiric seas? Very close to the continent or landlocked seas. Landlocked, close to continent, close to continents. Those type of seas are there, where you will get mostly platform deposits dominated by shale, sandstone, limestone. Limestone to me less, but it is there. They are not free. Epiric Sea. Either they are landlocked or partially connected to the ocean, main ocean. Like this, several places. You go to this side of China, east go. If you go to the other side of China, this is China. Here is Japan, Philippines. You will get several such seas, China Sea, South China Sea. Several seas are there, which are partly three sides they are covered by the continents. One side they are connected to Pacific, Japan Sea. These are Epiric seas. Epiric means surrounding, shallow. Continent margin surrounding, Epiric seas. So these are part of the big ocean, but along the margin of the continents. Remember, Epiric seas. aperic says, you see what I am telling. Suppose this is the ocean, you know. This is a big ocean. Ocean. So here there will be aperic. 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 So this one means the sea is connected to the continent. There will be small, either landlocked or they are partly connected to the main sea. And the same part so this is the deep ocean. Atlantic Sea, the mid ocean will be here. MOR, mid ocean will be here. Now this ocean will close. After 200 million years, say what I am telling you. Its lifetime has come. It is extremely loaded with the sediments. It cannot sustain anymore. So subduction zone will start. This subduction zone कहाँ होगा? We do not know. But it will prefer, you know, close to the mid ocean region. ये आसपास में कहीं होगा वो. ऐसे subduction इधर हो या इधर हो. It depends on several things which we will discuss. How a subduction zone is being created. Now, when the subduction zone will be created, then this becomes a different plate, this becomes a different plate, this is plate 1, say Europe, Africa plate, this is America plate, subducting. So these two will come together. And what will happen? You will get a great mountain belt, you know. Here, a mountain belt will be created here. So subduction zones will be much deep inside. The rocks will be metamorphosed, deformed, or what not. Granitic intrusion will take place. Mineralization will happen. You must have read about VMS, volcanometallic sulfides. Several types of deposits will occur inside this mountain belt. Because the ocean closed now. Ocean collapsed. So this is, you say, it is orogeny. Orogeny means mountain building phase. Ocean collapsing phase. So you are creating a mountain belt here in place of Atlantic or any ocean. Indian Ocean will also create a mountain belt like this. So all those sediments which are there, they will all crumble, deformed. And several things will happen which we will discuss in under subduction zone. But you just first get introduced to orogeny. Mountain building movement is called orogeny. Ocean closing movement is called orogeny. Now, ये दो आ गए, पास में हो गए, ये दोनों आ गए. बट बेचारा ये जो है ना, एपिओरोजेनिक सीज, एपेरिक सीज, वो तो आउटस्कर्ट में बैठा है. उसके नीचे कॉन्टिनेंटल क्रॉस इज एग्जिस्टिंग. चारों तरफ कॉन्टिनेंट्स आर हियर. कॉन्टिनेंटल क्रॉस इज एग्जिस्टिंग. और ओशन इज सराउंडेड बाय कॉन्टिनेंट. The continental rocks are lighter, granitic. They will not be pulled inside this subduction zone. It will be difficult. It will be difficult for them to go inside. So, ये जो कोर में जो sediments थे या rocks थे, oceanic floor sediments और rock, वो तो अंदर में जाके इसमें melting, building जो भी होना हो जाएगा. But those who are in the apparent part, they will be partially deformed, or they will remain undeformed. So, if you draw a post-orogenic figure, ऐसा ये तो माउंटेन बर्ड हो गया ये यहाँ there will be some still aperic sediments aperic seas वो क्लोज नहीं होगा डिफॉर्म हो जाएगा कुछ still will be existing, old sea will be existing, but वहां तो this orogenic movement will not reach यहाँ तक पहुंचेगा नहीं. So if you see some totality, you will find highly deformed, metamorphosed, sheared, granitic intrusions, and what in this belt, whereas there will be sediments, same age, similar age is same, but they are not deformed, they are not metamorphosed, they are not sheared, no granitic intrusion. As less as they will be sitting, Why you understood now? Because they are in the aperic part, away from the subduction zone. They are underlain by a continental crust, which will not be subducted. So, you name this part as mobile belt, this part is platform sequence. This is mobile belt. This is platform. So, this is pier. You will find every mobile belt or orogen will be flanked by the platform sediments. Platform sediments are as old as these sediments, but they have been differently treated. This has undergone subduction. This is still lying like that. Marginally you will get deformation. So marginal deformation will be there. But no metamorphism, no granitic intrusions. कुछ भी नहीं होगा उसमें. Very fresh. So mobile belt and platform forms a pair, So this part will no longer see. Sea will vanish. They will be just lying over the continent. Sea बहुत rarely मिलेगा. Sea नहीं रहेगा. All sea will be dried out. Very rare. You may find one or two continental sea, epicontinental sea, very deep inside. But all will be, dried out and rocks will be lying just open. Platform rocks. Because they are sitting idle. Nothing has happened to them. But here, lot of mobility. Mobile belt, why mobility? Because these two plates came together. Mobile. Plates are mobile. Deformation happened, metamorphism happened, lot of flow of the material become ductile, melted, all those things gives the name called mobile bed. But this is not a mobile bed. So, this is going to happen to Atlantic, this is going to happen Indian Ocean, this is going to happen Pacific Ocean. This I am talking about future. But how about the past? Just see. Past means Himalaya, Himalayan mountain belt is out of Tethys. So it is extending to Alps. Pura. So the Tethys ocean must be having its apparent part. Caspian Sea is aperic sea. वो टेथिस का पार्ट है, एपेरिक साइड में था, ये क्लोज नहीं हुआ अभी तक, इट इज स्टिल एग्जिस्टिंग. इट हैज रॉक्स, पैलियोजेइक रॉक्स एज इन हिमालय. हिमालय में पैलियोजेइक रॉक्स आर देयर ना, टेथिस रॉक्स, पैलियोजेइक रॉक्स आर देयर इन हिमालय. You will also find पैलियोजेइक rocks here. There are several such small oceans, existing close to Alps. So those are aperic seas. And some seas are dried out, and the aperic rocks, platform rocks are exposed. This is the story in Paleozoic. But how about Proterozoic? Proterozoic time में क्या हो गया था? Proterozoic time there are also mobile belts, mountain belts. So you have time, na? Yeah. Okay. Now see, I will draw. Then I will show you the map. थोड़ा आप भी ड्रॉ करो. If you know, no necessity of drawing very well or we will give the Indian examples. We have a chain of mountain belts, Proterozoic mountain belts in India. India is famous for Proterozoic mountain belts. Orogens, mobile belts, I am telling. Now you understood what is a orogen, what is a mobile belt, what is a mountain belt. See, Mahabaleshwar is also a mountain belt. We will not include it there. But we are talking about Aravalli. Then came the Satpura, take a turn for Satpura, Aravalli, then comes Singhbum, then Eastern Ghats, then down below Southern granulite terrain. Proterozoic mountain belts are there in India. Aravalli se chalu karo. Then Satpura came, Singhbum, Eastern Ghats, Southern granulite terrain. These are Proterozoic orogen or Proterozoic mobile belt or Proterozoic mountain belt. आपको तो एमएससी में फील्ड करने के लिए कोई चांस ही नहीं मिला. Otherwise you would have sent to some other place, some other mountain belt like Aravalli आप जाते. We will read individual belt, in this class. Good now. Deformation. F1, F2, F3, F4. Shear zones. Niroj is working in Ambaji area. Ambaji is an area where granulites are exposed. High grade whatever rocks are there. He is finding mineralization. Copper-lead mineralization in those granulites. Characteristics of a mobile belt. I told you. Then comes Satpura. Satpura is also known as CITZ, Central India Tectonic Zone. ये समय नर्मदा ताप्ती रिवर it goes. Then Singhbum, you know, Tatanagar, those areas, Singhbum mobile belt, copper mineralization, leaves at the metamorphism and faults and granitic intrusions. Dalma lava is a very important rocks in Singhbum mobile belt. Then come the Eastern Ghat mobile belt, full of granolites, charnokites, condalites, leptinites. Eastern Ghat mobile belt. Then come to Southern granolite terrain, condalites, charnokites, dendrites, what not? High grade metamorphism. All these things represent that big ocean, you know, very deep ocean, which was closed or collapsed, forming this gigantic mobile belt, Proterozoic mobile belt. Proterozoic mobile belt. Remember, ये सब नाम you have to remember. Gradually will come to your mind, you know. What is mobile belt? What is orogen? All these things should be in your hand. Now I will ask, where is the platform? Where is the etheric part? This is the core part of the ocean. Where is the etheric part? Etheric, now you understand the word etheric. Margin, close to the continent. Yet the big ocean, that's like the Atlantic Ocean, it was opening. In narrow belt you are seeing because it crumbled, it collapsed. But this Proterozoic ocean was some 2,000, 3,000 kilometers wide, just like your Atlantic Ocean. India was not a single country or single landmass when this ocean was existing. Just like one side America is standing, other side Africa is standing. Similarly, Maharashtra was standing one side, UP was standing on the other side. Big ocean was existing. That formed the origin of the mobile. But what about the platform? Now you can name. Because if you know Indian geology, you can name them. Vindhyans. यहाँ विंध्यान है, विंध्यान, shale sandstone, थोड़ा limestone, रह गया, it didn't touch. Aravalli जब deformation हुआ, when the mobility happened in the Aravalli, it set like that. It was on the outbound में था, विंध्यान. Then Chhattisgarh, important thing I am just telling. Chhattisgarh, Khariar. Most important is Kadapa. And here Bhima, Kaladgi, important epiric seas, epiric deposits. There is one more. Whether you have heard Krishna Godavari basin, you know, no? Pranita Godavari basin. यहाँ Pranita Godavari. Who will read? Pranita Godavari. That is also epic. Pranita Godavari is famous in your mind for Gondwana. Gondwana तो बात में आएगा भाई, फ्रेश वाटर. वो छोड़ो उसको. Pranita Godavari में भी ये Proterozoic rocks are there. Just like Kadapa Proterozoic, Chhattisgarh Proterozoic, Khariar Proterozoic, Vindhyan Proterozoic, because they are etheric of this mobile belt, you know. So ये भी उस वक्त the same time it was definitive. Unfortunately or fortunately, they were not affected by this orogeny. Similarly, along Krishna Godavari or Ranita Godavari, you have these things. You must have heard the name of what is that? Proterozoic rocks. On either side it is there, no? Pakhals. Both sides. Proterozoic rocks. Horizontally padded rocks. Nothing has happened to them. Pakhal. Gondwana came later. वो भी पढ़ेंगे हम. पहले we should finish this aperic part. So these are the main aperic seas or aperic deposits in India, which you say the platform deposits. You understand now what is the difference between platform and the mobile bed? Same age will be same. They are not different. Age will be same. But one will be extremely deformed, metamorphosed, mineralized, granitized, where the other one will remain as fresh, horizontally bedded, marginally deformed, no metamorphism. Those are the characteristics of the platform. So, one is produced from the mobility. The other one is produced from, it's like that, deposited in the margin of the continents. Some oceans were surrounded by the continents. Intracontinental seas were there. That is how these platform sediments were deposited. So this is the story of Proterozoic in India. Proterozoic sea, Proterozoic platform, Proterozoic mobile bed. So you may be getting interested, no? इस Proterozoic time में जो tectonics था, Proterozoic tectonics, then it was similar to the modern tectonics. The Cenozoic tectonics. Ocean will close, it will form mobile bed, it will form platform, all those things, goes under plate tectonics. So this plate tectonics was operative right from the Proterozoic time. Early Proterozoic, you can say late Archean, early Proterozoic. It was continuously happening. During Archean time, it's still doubtful. Some people say no, late part of Archean we have plate tectonics. That means this type of oceans were existing, orogeny happened. But some people say no, during Archean time there was no orogeny. There was no plate tectonics. So there are some contradictory views or two views, not contrasting, two views. Yes, plate tectonics, no plate tectonics during Archean. So if you read some papers, Archean plate tectonics, you will find what is that contrasting views, where there is a debate over it. During Archean time, the crust was very hot. Hot means ductile, very soft, Archean. So it was not forming such a large ocean. It cannot form such a large ocean. To form a large ocean, you need a thick continental crust. You need it to be cool and brittle. Then only the ocean will be formed. Otherwise, it will not form. So during Archean time, it was not there. So people say Archean time there are no plate tectonics. The plate tectonics started from early Proterozoic. Maybe. But so far as India is concerned, we have Proterozoic mobile beds, Proterozoic platforms. So now what we will do with this, I will cover some of these Proterozoic mobile beds and Proterozoic platforms fast in this class. Because some introduction to plate tectonics, BSc time, but keeping that in mind, I will be covering these two units, Proterozoic mobile beds and Proterozoic platforms. First, we will go in this sequence. Now, you cannot believe that this topic, is very interesting in this sense, So ultimately, you may join some professional organization like Geological Survey of India or NGRI or AMD, where this subject particularly, Indian geology, Indian tectonics, these topics are of much use, much interest. So I'll not boast myself, in the training institutes, they have downloaded some of my YouTube lectures in the training institutes and have made it a syllabus for them. So you should take a keen interest in this topic. How these mobile band platforms, played a great role in forming this Indian subcontinent. How the Indian subcontinent evolved through time, from Proterozoic to Phanerozoic to descent. How it evolved. So Archean part we will take up little later. So in this sequence we will go. So next class what I will do, I will cover this platform sequences first. Something very interesting. Then next we will take up some Gondwana. That is further interesting. Then mobile bands, then other parts will go. In this sequence we will go. So okay. So I will stop it here. Next class we will see.